Hello friends, welcome back to my channel. Today we are going to solve a popular DSA problem. The problem is find all subarray of a given array. And the statement is given an array of integers, print all possible contiguous subarray of the array. So what is subarray? A subarray is a contiguous part of an array that are next to each other and maintain the original order. Hope you understand the subarray. Let's check the subarray for the given example. The input has given 1, 2 and 3 and the subarrays are 1, 1, 2, 1, 2, 3, 2, 2, 3 and 3. And now we'll go for a brute force idea to solve this problem, like how we're getting this subarray for the given input. To find the all subarrays, we use two nested loop. The first loop is outer loop. It selects the starting index, and the second loop is inner loop that select the ending index. Then we slice the array using those indices. After the loop's end, it will return or print all the subarrays. Here's the code. Now I've written n equal to len of array. Here we are sorting the length of the array into the variable n. And after that, we started with a loop for I in range of n. This means the start it will start from I index and will go from 0 to n minus 1, where n is the length of the array. In simple word, we are picking the starting point of each subarray. For example, array like 1, 2, 3. The start will be index 0, then it will go to 1, then it will go to 2. Okay, and inside that loop, we are writing another loop that is for j in range of I comma n. This picks the ending point of the subarray. The trick here is we start j from current I, not from 0. Why? Because subarrays are contiguous and they must begin at I and extend up to j. So for I equal to 0, j will go from 0 to n minus 1. And for I equal to 1, j goes from 1 to n minus 1 and so on. Now I've written subarray equal to array of I colon j plus 1. Here we extract the subarray using slicing of this array of I colon j plus 1. But why I've written j plus 1 here? Because Python slicing include sorry because Python slicing exclude the last indices. So if we want to include the element at j, we need to go one step further. Okay, and for this code, I have given time complexity as big O of n square. Why? Because outer loop runs n time start from 0 to n minus 1 and inner loop runs approx n minus I times for each I. So total number of iteration across both loops will be big O of n square, and the space complexity here is big O of 1 if we are just printing, and if we are storing subarray in a list where k is the total number of elements, then it will be big O of k. Okay, now we'll do a quick dry run for this example. Okay, so here we have used two loops, right? I go from 0 to n minus 1, and for each I, the j goes from I to n minus 1. So here the iteration and subarrays are given, and now we'll iterate and see the subarray for each of the iteration. First, I put first I equal to 0. Okay, we are starting at index 0 and ending at index 0. Here we are starting as index 0 and ending at uh, index 0. Both are in index 0. So we have the subarray as 1. Next, we extended the j equal to 1 to index 1, right? To index 1. I mean, here we extended j equal to index 1. So the subarray become 1 comma 2. Now j become here, I mean j become 2 means we have added the j equal to second index, and the subarray will be 1 comma 2 comma 3. You can say full array. Now we move I equal to index 1. Okay, and j equal to index 1. You can say both I and j are at index 1, so we get 2 of subarray. Now expanding j to index 2, j to index 2, and it gives us 2 comma 3. Finally, I moves to index 2, right? So I and j both at index 2, and it gives up the last subarray of 3. That's how the nested loop print all possible contiguous subarray. Now we'll look this code into the lead code, and we'll check whether we're getting the expected output or not. So let's go to lead code. Here in lead code, I will write the code again and we'll check whether we're getting the expected output. Okay, so I've written the function, but now after that I've written n equal to lineup array. Now I write the outer loop like for I in range up n. Then I write the inner loop for j in range I comma n. After that we write the slicing here. So subarray equal to array of I colon j plus 1, and we'll print the subarray. Print subarray. Now let's check. Yes, we're finding the expected output. Okay, in the same code, after doing some modification, we can solve two more subarray questions here. So the questions will be like sum of all the subarray, and we can solve one more question like find the maximum sum in a given subarray. So in the same code, we'll do some modification, and we'll get the output for those code as well. So let's do some modify here. So okay, let's change. We can change here like sum of all. You can say sum all subarray. Sum all subarray. Here we have to initialize total sum equal to 0. Then you can use the same loop here, and to find the total subarray, we have to increment that. So we have just increment this, and you have to print the return the subarray, right? I have to return that actually. Return total sum. Here I have to write that total sum, right? Total sum. We can do it here. Yeah, not here. Here we have to increment that equal to sum of subarray. Now let's check this code. I think we have done okay. We have to change here also. So what I've written here, just check with sum all subarray, right? Okay. Okay, now check. Yes. So we found a total subarray is 20. So let's verify this. So we have to add this subarrays. Like we can add like 1 plus 3, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 5, 17 plus 3, 20. Yes, it's verified. So total, I mean, sum of all subarray is coming 20. Now I will do some modification again and try to find the output for find maximum sum of the subarray, right? Maximum sum of subarray. So let's do some modification and try to get the output as well. And guys, like if you want the specific code, we can just take a screenshot for first problem, then this problem, and the uh, find the maximum sum of summary. That also you can take a screenshot for your reference. Now I'm doing some modification and I will get the output for that problem. Let's do it. So we have to erase this one. Here we can write, you need actually maximum sum, right? So let's see, max sum summary. Initialize here like max sum, because we have to maximum sum, so we have to take care of the like some edge case here. So here we will take care of the infinite, like it's with initializing for to negative infinity, right? What if like the values come negative? So for that I'm just initializing this uh, plot of minus in infinity. Okay, now uh, with the same outer loop, now here I have to uh, like we have to get the sum, right? Then we have to find the maximum. So to get in the sum, we have to again initialize, like for example current sum equal to 0. I'm just initializing this thing here, and after that the sliding part will be the same, and here you have to find total sum. Total sum also will be same, but here you have to just mark it equal to, and after that we have to what happened? Okay, after that we have to find the max sum, right? Max sum equal to, have to max up, like we have to compare between max sum and total sum, you can say, right? Max sum comma total sum. Here also I have to change, I can make it total here, total sum. Here I have to find max sum, right? So make it max sum, and while taking the output I have to change here as well as max sum array, as max sum array. After that let's check if everything fine, index all the, yeah, I've taken everything. Let's check. Yes, you got the output. So we can say first of all, the first problem, find the subarrays. So we found the subarrays, right? And second problem, we found the sum of all the subarrays, it is 20. And the third problem is to find the maximum sum of subarray. So here in this output, the subarrays we got, we can see here this is the maximum subarray, right? 1 2 3, and sum of this subarray is 1 plus 2 3 3 plus 6. So it is coming correct here. Okay, so I hope you understand all three problems, and for your reference, please take the screenshot for each of the problem, so that you can practice by your own. And I think that's it for today's. And now let's will go for recap and call to action. So uh, the final recap and call to action for today is, we have solved three classic subarray in DSA, subarray problem in DSA. And the first one is print all subarray. I've used two nested loop to generate all the contiguous subarray with slicing, like array of start plus start colon n plus 1. Okay. The second problem was sum of all the subarrays. For that, we have calculated the sum of each subarray and added it to a running total. And the third problem was like maximum sum of all the subarrays. So for that, we have found the sum of every subarray and kept track of the maximum value, and whichever the maximum, we got that as output. And yes, if this video helped you, so please show some love, like the video and subscribe to Make Easy Code, that is my channel, for more easy DSA video. So that's all for today. Thank you for watching. See you in the next video.